Have you ever wondered what reality truly is? Is it what we perceive, or is it woven with threads of quantum uncertainty? Welcome to the perplexing world of quantum physics, a realm where the rules of the macro world do not apply. Here, particles can exist in multiple places at once, and the act of observing can alter reality. Picture this: a particle behaving as both a wave and a particle, defying the very fabric of our understanding. This is the wave-particle duality, a cornerstone of quantum physics. Then, there's the uncertainty principle, which tells us we cannot simultaneously know the exact position and momentum of a particle. It's as if the universe has a built-in veil of mystery. Quantum physics pushes us to question the nature of reality. As we delve deeper into this quantum world, the line between what is real and what is potential starts to blur. Our understanding of reality begins to blur as we delve deeper into the quantum world. The Double-Slit Experiment, a cornerstone of quantum physics, shatters our conventional understanding of reality. This experiment stands as a testament to the surreal nature of the quantum world, where particles like photons can behave both as particles and waves. Imagine you're throwing pebbles into a pond with two slits in a barrier. The pebbles, being matter, would pass through one slit or the other, creating two separate patterns on the other side. But what if we replace the pebbles with light particles or photons? You'd expect the same result, right? Well, that's where the universe throws us a curveball. Instead of two separate patterns, we get an interference pattern, as if the photons are behaving like waves and passing through both slits at the same time, interfering with themselves. This is where the wave-particle duality concept comes into play. It's as if the photon is saying, why limit myself to just one path when I can explore all possibilities at once? But here's the real kicker. If we decide to observe which slit the photon passes through, the interference pattern disappears. Suddenly, the photon starts behaving like a particle again, passing through one slit or the other, but not both. It's as if the very act of observation changes the behavior of the photon, making it choose a definite path. This is known as the observer effect, a phenomenon that's still a hot topic of debate among physicists. This experiment, as simple as it may seem, has profound implications. It suggests that at the quantum level, reality is not fixed until it's observed. It's as if the universe is saying, I won't decide until you look. It's a concept that challenges our understanding of reality and opens up a world of possibilities that seem more like fantasy than science. In the realm of quantum, observing is not merely seeing, it's an act that shapes reality. Quantum computers, a product of quantum mechanics, are redefining the boundaries of computation. Imagine a computer so powerful that it could solve problems in seconds, which would take a conventional computer thousands of years to crack. Welcome to the world of quantum computers, but what makes them so special? At the heart of quantum computing lies the concept of a quantum bit or qubit. Unlike classical bits, which can be either 0 or 1, qubits can exist in both states simultaneously, thanks to a principle known as superposition. This allows quantum computers to process a vast number of possibilities all at once, promising a computational speed that classical computers can only dream of. Then there is entanglement, another quantum phenomenon. When qubits become entangled, the state of one qubit becomes directly connected to the state of another, no matter the distance between them. This mysterious connection enables quantum computers to work with an incredible level of synchronization. Now, let's highlight the differences between classical and quantum computers. Classical computers are great at tasks that can be broken down into simple procedures. Think of them as really fast, diligent clerks. Quantum computers, on the other hand, are like creative geniuses. They excel at problems that require exploring a huge number of possibilities, like finding the optimal route for a traveling salesperson or simulating complex chemical reactions. But the potential applications of quantum computers go beyond just number crunching. They could revolutionize fields like cryptography, creating codes that are almost impossible to crack. In medicine, they could help design new drugs or analyze DNA sequences with unprecedented speed and accuracy. And in artificial intelligence, they could help create more sophisticated machine learning algorithms. However, building a practical quantum computer is no easy task. It requires maintaining qubits in a delicate state of superposition and entanglement, which is easily disrupted by environmental factors. But every day, scientists are overcoming these challenges, bringing us closer to the quantum revolution. Quantum computers, a bridge between our reality and the quantum world, hold the promise of a computational revolution. Quantum teleportation, once a sci-fi fantasy, is now a scientific reality. It's a process that seems to defy the laws of our everyday world, teleporting information from one place to another instantaneously. But how does it work? To understand quantum teleportation, we need to dive into the world of quantum physics and understand two fundamental concepts: quantum entanglement and quantum connection. Quantum entanglement is an unusual aspect of quantum physics where two particles become linked and can instantaneously affect each other, regardless of the distance separating them. It's a bit like having two dice that, no matter how far apart you roll them, always land on matching numbers. Quantum connection, on the other hand, is the process of entangling these particles. It's the bridge that links these particles together, allowing them to communicate instantaneously over vast distances. Now, when we talk about teleportation, we're not talking about physically transporting matter from one place to another. Instead, quantum teleportation is about transferring information about the state of a quantum system. It's like sending a detailed blueprint of a house to a builder on the other side of the world, who then constructs an exact replica. This concept opens up a world of possibilities. It could revolutionize communication, creating secure channels that can't be intercepted or hacked. It could also lead to breakthroughs in quantum computing, giving us the ability to perform complex calculations at lightning-fast speeds. Quantum teleportation, a leap from reality to fantasy, heralds a new era of communication. Parallel universes, a product of the many worlds hypothesis, challenge our understanding of existence. This idea, born from quantum physics, proposes that our universe is only one of an infinite number of universes, each existing parallel to our own. It's like tuning in to different radio stations with each universe playing its own distinct song of reality. The many worlds hypothesis, conceived by physicist Hugh Everett in the mid-20th century, takes quantum physics to a whole new level. It suggests that every time a quantum event happens, say an electron deciding to spin up or down, the universe splits into two. In one universe, the electron spins up. In the other, it spins down. Each universe is as real as the other, and this process happens countless times, creating an unimaginable number of parallel universes. But what about interactions between these universes? While most physicists believe that these universes exist in isolation, some theorize about the possibility of communication or even travel between them. This is purely speculative and currently beyond our scientific capabilities, but it's a tantalizing thought that stirs the imagination. Quantum physics, with its counterintuitive principles and mind-bending theories, encourages us to look beyond the reality we perceive with our senses. It invites us to consider a realm of infinite possibilities, where every eventuality exists somewhere in the multiverse. Parallel universes where our reality may be just one of countless others, open a portal to infinite possibilities. Quantum physics isn't just science, it's a muse inspiring art and philosophy. This fascinating field has been the stimulus for many artists, pushing them to explore the seemingly paradoxical concepts of quantum reality in their work. Quantum physics challenges our perceptions, asking us to consider that particles can be in two places at once, or that an object's properties aren't settled until they're observed. In philosophy, quantum physics provokes questions about the nature of reality itself. It prompts us to ponder: do we shape our reality through observation, as the principles of quantum mechanics suggest? Or is reality independent of our perception? Moreover, quantum philosophy encourages us to think about causality, determinism, and the concept of now. Quantum art, on the other hand, strives to visually depict this abstract world, creating a bridge between the hard science and our human experience. In the quantum world, reality and fantasy intertwine to create a canvas of infinite possibilities. The quantum world, once a realm of fantasy, is becoming an integral part of our reality. As we stand at the dawn of the quantum age, we can only marvel at the possibilities ahead. Quantum technology is poised to revolutionize many sectors, from computing and telecommunication to medicine and material science. Yet the journey to this future is not without its challenges. Quantum physics is a complex field requiring substantial resources for research and development. We are still grappling with the mysteries of the quantum world, which often defies our conventional understanding of reality. Moreover, practical applications of quantum principles, such as quantum computing and quantum teleportation, are still in their infancy. These technologies promise immense potential, but they also pose significant technical and ethical challenges. Despite these hurdles, the pursuit of quantum knowledge continues unabated. The journey from reality to fantasy is just beginning. Welcome to the quantum age.